Hello everyone, very warm welcome to Venkat Varma Chemistry YouTube channel. I am Venkat Varma, your chemistry host and enthusiast. I hope all are doing well. In this session, we are going to learn carbonyl compound in revision in one shot. Carbonyl compounds means aldehydes and ketones. Aldehydes and ketones, methods of preparation of aldehydes and ketones in one shot revision. Let's start our session. Carbonyl compounds means aldehydes and ketones. Let's start. See, the general methods of preparation of carbonyl compounds means aldehydes and ketones. Aldehydes and ketones are called carbonyl compounds. Yes, the first method is oxidation of alcohols. Oxidation of alcohols to give carbonyl compound. See, the oxidation of primary alcohol. See, oxidation of primary alcohol. Primary alcohol in presence of oxidation, the reagent is potassium dichromate K2Cr2O7 in H2SO4, dilute H2SO4 to give aldehyde. Primary aldehyde, oxidation to give aldehyde. Now secondary alcohol to give ketones. See, secondary alcohol oxidation in presence of potassium dichromate K2Cr2O7 in dilute sulfuric acid to give ketones. Yes, primary alcohols to give aldehyde, secondary alcohol to give ketones. Yes. Now, the mild oxidizing agents. See, the mild oxidizing agent. What are the mild oxidizing agents? They are Collins reagent. Collins reagent means CrO3, chromic oxide in pyridine. That is a Collins reagent. And PCC. What is PCC? Pyridinium chlorochromate. PCC. Yes, it is a CrO3 plus C6HO5N plus HCl. This is a PCC. Yes, this mild oxidizing agent, the primary alcohol oxidation to give aldehydes. And water. Yes. What is the next method? Generally what? Primary alcohol oxidation to give aldehyde, secondary alcohol to give ketones. Yes. What is a mild oxidizing agent? PCC, PDC, Collins reagent. Okay. And Jonas reagent also. See, Jonas reagent. These are the mild oxidizing agent. Yes. Now, the second method is dehydration of alcohols. Dehydration, removal of water from alcohol. What is the reagent? The reagent is copper at 300 degrees Celsius. See, primary alcohol in presence of copper at 300 degrees Celsius to give aldehyde, acetaldehyde, CH3CHO, acetaldehyde. Yes. Now secondary alcohol, CH3OH in presence of copper at 300 degrees Celsius, it gives acetone. Yes. It is a acetaldehyde, it is a acetaldehyde. Primary alcohol to give aldehyde means acetaldehyde. Yes. Now secondary alcohol to give ketones means it is a acetone. Now coming to tertiary alcohol. tertiary alcohol oxidation in presence of copper at 300 degrees Celsius to give alkene. That is the isobutylene. It is the isobutylene. Yes. Remember, tertiary alcohol in presence of copper to give alkene. See. Have a look for question. It is what type of alcohol? It is a secondary alcohol. Yes. Secondary carbon with alcohol. Yes. In presence of oxidizing agent, Jonas reagent, CrO3, H2SO4, H2O in acetone. So what happened? This oxygen attacks over on hydrogen. What forms it forms? See, this is the OH and OH. Carbon having two OH groups. It is unstable removal of water to form a ketone. Yes, to form a ketone. See. Next is a dry distillation of calcium salts of carboxylic acid. See, distillation of calcium salt of carboxylic acid. I am writing reaction. See, calcium alkanate or C double bond O Ca O C double bond O R. It is what? It is a calcium alkanato. See, calcium alkanato. S Ca O C double bond O and H. Yes, it gives what? See, gives see RCHO plus 2CaCO3 CaCO3. Yes, and RCHO RCHO. Yes, sorry. This is the see. Yes, RCHO. Yes, RC double bond H aldehyde. Yes, same as C. Ca in presence of calcium salt of C or C double bond O Ca C double bond O R in presence of Ca O C double bond R O C double bond R heating, it gives ketones to C double bond R plus 2CaCO3. Yes, like that. To form a ketones and CaCO3. Yes, this is a dry distillation process. Have a look for thermal decomposition of carboxylic acid. See, thermal decomposition of carboxylic acid. See, carboxylic acid. See, I am writing carboxylic acid CH3 COOH. Yes, and CH3 COOH carboxylic acid in presence of manganese oxide MnO at 300 degrees Celsius to give what? H3 C double bond O CH3 CH3 plus CO2 plus H2O. Thermal decomposition of carboxylic acid. C. Okay, to form a ketone. And aldehyde also forming COOH, COOH, same reagent MNO at 300 degrees Celsius to form a CHO plus H2O plus CO2. Yes, like that OH. This is the aldehyde, thermal decomposition of carboxylic acid. I will look for next method. Ozonolysis of alkene. The ozonolysis of alkene already we are discussing in alkene chapter. Once again, look at for the reaction. For example, alkene RCH double bond CH2 in presence of ozone. What happened? Breaking of double bond, keeping of oxygen. Yes, to form a RCHO plus CH2O. Yes, I am writing in short. zinc and water. Yes. What are the ozonolysis reagents? Ozone with zinc in water, ozone in zinc in water. Next, see. What is the reagent? Ozone, carbon tetrachloride in zinc, ozone, carbon tetrachloride, zinc and water, ozone, carbon tetrachloride, dimethyl sulfide. See, I am writing next example. R, C double bond, C, H2 and R. In presence of ozone, see carbon tetrachloride, zinc in water. What is the product? C, breaking of double bond, keeping of oxygen to form a C double bond, RC double bond O, or aldehyde is formed. Ketone is formed, and again CH2O. It is aldehyde. It is a ketone. This is the ozonolysis of alkene. Have a look for next method. Kucherov reaction are acid catalysis, hydrolysis of alkane. This reaction also we are discussing in alkyne chapter. So once again I can revise. See, alkyne, CH triple bond CH in presence of what is the reagent? H2O plus H2SO4 in presence of Hg2 plus. It gives what? Vinyl alcohol CH2 double bond CHOH. Yes, it is tautomerized. To form a CH3C double bond H. It is tautomerism. Yes, it is a acetylene, means alkyne. I am taking question. For example, CH3C triple bond CH in presence of H2O and H2SO4 Hg2 plus. What is the product? See, here CH3. So this pi bond is shifted. Shifted. H plus OH minus. So you are getting partial positive charge. You are getting partial negative charge. Negative charge moves to positive side. Positive charge is moves to negative side. Here CH3 COH SC double bond CH2. Here also tautomerized to give CH3 C double bond CH3. It is a aldehyde. It is a ketone. It is a aldehyde. What is the name of the reaction? Kucherov reaction or acid catalysis, hydrolysis of alkyne. Yes, have a look for next reaction. See, have a look for reaction. See, in presence of manganese dioxide, MnO2, what is the product? Means it is oxidation. This oxygen attacks over an hydrogen to form a COH, CH2, CH3. This OH has diol. It is unstable. It form PHC double bond O CH2 CH3. Yes, minus loss of water, H2O. Yes, now have a look for this alkene system, 2-methyl, 1, 2, 3, 4, 2 butene. Ozonolysis, what is the product? Very simple, breaking of pi bond, keeping of oxygen, CH3, double bond CH3, acetone. And what is the next? CH3, CHO. CH3, CHO. This is related to general methods of preparation of aldehydes and ketones. Aldehydes and ketones. Let's move on. See, general methods of preparation of aldehydes only. The name of method is Rosenman reduction. The Rosenman reduction, it is the conversion of acyl chloride to or acyl halide to aldehyde. Acyl halide to aldehyde. What is the reagent? What is the reagent? See, the reagent name is palladium barium sulfate. Palladium barium sulfate. In this method, formaldehyde cannot prepared by using Rosenman reduction. See, or C double bond O with Cl reduction with a hydrogen palladium in barium sulfate to give RCHO. Yes, again it is converted to RCH2OH. Yes, further reduction. So palladium barium sulfate, the BaSO4 control the further reduction of aldehyde to alcohol. Remember, palladium barium sulfate BaSO4 to control further reduction of aldehyde to alcohol. Yes, in this method formaldehyde cannot prepared. It is conversion of acyl halide to aldehyde. Yes, now for example, look at the question. CH3 or C2H5 C double bond Cl. Yes, in presence of palladium barium sulfate. What is the product? C2H5CHO plus HCl. This is the product. Have a look for next method. This is only for preparation of aldehydes only. Yes, now looking for Stephan reaction. What is Stephan reaction? See, alkyl cyanide RCN to aldehyde. What is the name of reagent? Tin chloride SnCl2 plus HCl to give aldehyde. Look at for R C triple bond N S reduction with tin chloride SnCl2 plus HCl to give imine RaRCH double bond NH. It is a imine hydrolysis to form a aldehyde RCHO plus NH3. Ammonia is produced. Okay. For example, have a look for C2H5 C triple bond N reduction with Stephan reduction SnCl2 plus HCl. What is the product? It gives what? Imine. It gives imine. C2H5 CH double bond NH. Yes, it is further hydrolysis. It gives C2H5 CHO plus NH3. This is for Stephan reduction. Have a look for question. Toluene in presence of chromyl chloride to give what? Benzaldehyde is given. It is a Etard reaction. Again, it is alkene system with alcohol CH2 double bond CH2OH in presence of manganese dioxide MnO2. So this CH2OH is converted to aldehyde, CH2 double bond CHO. It is converted to aldehyde. Have a look for next question. See, this alkene system in presence of ozonolysis, what is a product? It gives CH3CHO, yes, and CH3CHO, yes, and methyl cyanide in presence of diol hydride. What is a product? CH3 C triple bond N. This CN is converted to CHO, CH3 CHO reduction. Have a look for next question. See, sodium borohydride. Sodium borohydride reduction. Sodium borohydride reduction. What happened? Here breaking of pi bond, keeping of hydrogen. Yes. Here also hydrogen to forming. See, to forming alcohol. To form a alcohol. Again, CrO3, chromic oxide. The alcohols are, see, primary alcohol is converted to aldehyde. Yes. 1 2 3 4 5 6. 1 2 3 4 5 6. Yes. See, have a look for properties, chemical properties. It undergoes nucleophilic addition reaction. See, nucleophilic addition reactions. Nucleophilic addition reactions. In the first reaction with hydrogen cyanide. See, reaction with the hydrogen cyanide, HCN. HCN. See, I am writing C double bond O in presence of HCN, hydrogen cyanide. It means H plus Cn minus, pi bond shift and positive and negative. Yes, to form a C O H and Cn. It is a cyanohydride. It is a cyanohydride is formed. Cyanohydride is formed. Yes. Have a look for next reaction. See, very simple. Opposite charge moves to positive, charges moves to negative, negative charges moves to positive. Yes. Now coming to second reaction with the NaHSO3, NaHSO3. Yes. For example, carbonyl compound in presence of NaHSO3. NaHSO3 means Na plus HSO3 minus, pi bond is shifted, positive negative charge. What formed? COH and SO3Na. SO3Na. Yes. And this HSO3Na. Yes. Now have a look for next reaction. Reaction with alcohol. Reaction with alcohol. See, carbonyl compound with alcohol, ROH. So it is what? RO minus H plus, pi bond is shifted, positive negative charge. It forms OH and OR. It is a hemiacetal. It is a hemiacetal. Have a look for same carbonyl compound in presence of 2 moles of alcohol. 2 moles of alcohol. 2 moles of alcohol. What happened? Attacks. See, pi bond is shifted, positive, negative. Yes. C double bond OR. OR. Yes, it is acetal. 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 Yes. Next reaction. Carbonyl compound with CH2OH and CH2OH. CH2OH and CH2OH. It gives COH and CH2 CH2. It is cyclic acetal ketal. It is a cyclic acetal ketal. Cyclic acetal ketal. Yes. Next, see reaction with NH2 with Z. Reagent name ammonia. Z means H. R NH2 NHPH OH NH2 COH. See carbonyl compound with NH2 with Z gives H minus H2O to form a carbon double bond NH. Here Z is NZ is H R NH2 NHPH OH NH2 CONH2. So the reagent name ammonia to form a product is C double bond NH. If the reagent is primary amine, it is carbon double bond with NR. The reagent is hydrazine NH2 NH2, car double bond NH2. Yes, phenylhydrazine, phenylhydrazone, hydroxylamine, NH2OH, NH2OH, hydroxylamine, carbon double bond with NOH. Semicarbazine, it gives semicarbazone, carbon double bond with NHCO, NH2. This is a Z term, this is a reagent name, this is a product. See, have a look for next one. See. Phenylhydrazine. It gives 2,4 diphenylhydrazone, carbon double bond with NNH with NO2 and NO2. It is a 2,4 dinitrophenylhydrazone. It is a Brady's reagent. Have a look for the reaction with the Grignard reagent. Formaldehyde with the Grignard reagent, it gives primary alcohol. Aldehydes with the Grignard reagent, it gives secondary alcohol. Ketones in presence of Grignard reagent, it gives tertiary alcohol. Yes. Have a look for question. See. See. CH3 C double bond CH2 CH3 Na plus HSO3. What is the product? See, pi bond shifted, positive charge, negative charge. Here gives CH3COH. Yes. Here SO3 Na and CH2CH3. Yes. Have a look for next question. See. CH3CHO with methanol CH3OH, CH3O minus H plus. Yes, it forms CH3SC, HH and OH and OCH3. It is a hemiacetal. Yes, again CH3COCH3 with 2 moles of alcohol. 2 moles of alcohol. It gives what? See, pi bond is shifted, positive charge, negative charge. See, here CH3 attacks H, attacks OCH3 and OCH3. It is a ketal. Yes. Have a look for next question. See, CH3 CHO in presence of thiols SH and SH, it gives what? See, CH3 C S and S to form a CH2. So it is a reduction, means cleavage of bond, keeping of hydrogen. Yes, it forms in presence of hydrogen and nickel. It gives propane. The name of reaction is Mozingo reduction. reduction. It is a Mozingo reduction. These are the properties of aldehydes and ketones. I hope like this video. Don't forget to share your friends. Don't forget to give like. If you find content is valuable, make sure to subscribe our channel. Yes, and hit the bell icon to stay updated with the latest notifications. Thanks for watching.